So I want to talk about dividing imaginary and complex numbers. Let's take a simple example. Let's do 5 divided by I. Okay, so one comment to make is that typically when you write a complex number, you don't want I in the denominator. So that's one reason why you want to learn how to divide numbers like this. So what you can do is you can use the fact that I squared is -1 to simplify this. Okay, and so what you can do is you can multiply the numerator and the denominator by I. That way you're not changing the value of the fraction, but it will achieve getting rid of the I in the denominator. So when we do this, we get 5 times I, so that's 5I, and in the denominator we get I squared. Okay, well this makes it easier because I squared is -1, so we have 5I all over -1, which is -5I. And that's the answer. So you've rewritten it so there's not an I in the denominator. Let's look at another example where there's actually a complex number in the denominator. So let's say we want to divide 7 plus 2I and 1 minus 3I. So here we're dividing two complex numbers, but we want to divide and be able to write our answer in A plus BI form. That's our goal, okay? So we have to do something. We have to use some kind of trick or manipulation to get rid of the I in the denominator. And one thing that works really well is to multiply by the conjugate. So the conjugate of 1 minus 3I is 1 plus 3I. Okay, so in general, the conjugate of A plus BI is just A minus BI. Okay, that's where I'm getting that from. And because we're multiplying the denominator by 1 plus 3I, we also should do it to the numerator so that we're not changing the value of the fraction at all. Okay, and then I'm going to put parentheses around the 7 plus 2I because when I multiply, I'm going to have to FOIL, and I have to treat these as two binomials. Okay, so let's go ahead and do this. In the numerator, I'm going to use FOIL. So 7 times 1 is 7. 7 times 3I is 21I, so that's 21I. And then on the inside we have 2I times 1 is 2I, so plus 2I. Okay, and then we have 2I times 3I is 6I squared, so it's plus 6I squared. I'm going to make my division line a little longer here. Okay, now in the denominator, because we're multiplying conjugates, the middle term is going to drop out, which is what we want to have happen. So let's do this. We'll use FOIL. So 1 times 1 is 1. And on the outside we have 1 times 3I is just 3I, so I'm going to put plus 3I. And then on the inside we have negative 3I times 1, which is negative 3I. And then the last terms are negative 3I and 3I. When you multiply those, you get negative 9I squared. Okay? And okay, so now we're in a good place because the 3i's cross out right here and right here. And that will always happen. Oops, I forgot squared there. That will always happen when you multiply by the conjugate. Well, you might be asking, okay, what about the I squared here? Well, that is -1. So we can get rid of the I there also. So let's continue this way. I'll work on the top first. So we have 7 plus 21i and 2i. That's going to be 23i. So, all right, division bar right here, going to have 7 plus 23i, okay, and then plus 6i squared. That's going to be plus 6 times -1 because I squared is -1. Okay, and in the denominator we have 1. The 3 i's canceled out, and then we have 1 minus 9 I squared, which is -1. So you can see this is gradually getting more and more simplified. Okay, let's continue. So now we have 7 plus 23i minus 6 divided by 1 minus, and that's going to be a -9. Okay, let's continue to simplify. I'll continue down here. So we have 7 take away 6. We can clump those together and just make that 1. So let me write the division bar again. So 7 minus 6 is 1, and then we have plus the 23i. And in the denominator, we have 1 minus a -9, which is 1 plus 9, which is 10. Okay, and we're almost done writing this in standard form. That's in a plus bi form, and all you need to do is separate this out into two fractions. So you have 1 over 10, so that's 1/10, plus 23 over 10 times I, and there it is. It's written in a plus bi form.